This is Algebra 1, Lesson 6.4, Solving Absolute Value Equations and Inequalities. Those are our goals today, to solve both of those, beginning on page 353 in your textbook. Example number 1 says solve, you read this as the absolute value of x plus 3 is equal to 11. Remember, absolute value talks about a distance from 0. So not just the right side of 0 where your positive numbers are, but also there's the same distance on the left side where your negative values are. So it says because the absolute value of x plus 3 is equal to 11, the expression x plus 3 can be equal to 11 or negative 11. So for the first one, solve it without the inequality, without the absolute value symbols, and make it equal to the positive number. X plus 3 is positive. So x plus 3 is equal to positive 11. So you just solve it like a one-step simple equation. Undo plus 3. When you do it to one side, you do it to the other side, and you get x is 8. That's solving it as a positive number. You can also solve it as a negative number. In fact, it's not that you can also solve it. You have to solve it both ways. The other way, when x plus 3 is negative, x plus 3 is equal to a negative 11. Again, you lose the absolute value symbols. You make one positive, you make the other negative. Again, you subtract 3 to undo the plus 3, just like we did for the first equation, and x plus 3 is equal to negative 14. So you have two answers. You have 8 and you have negative 14. Both of those numbers, when you plug them back in, give you 11. Let's check and see. The absolute value of 8 plus 3 is 11. That is the absolute value of 11, which is equal to 11. The absolute value of negative 14 plus 3, when you put those two together, you get the absolute value of negative 11, again, which is 11. That's how just checking using both of those numbers, 8 and negative 14, gives you a true statement because of the distance from 0, both on the right side in the positive numbers and the left side in the negative numbers. On the back side, do this problem. X minus 4 equals 8. Do it just like the example. Take about 45 seconds. It doesn't matter if you stack them or if you write them side by side. I often find it's a little easier to write them side by side because you can compare your steps right next to each other. X plus 4 equals a positive 8, and I said plus 4, I meant minus. X minus 4 equals a negative 8. Notice we don't change the minus 4 part. You don't change what's inside the symbol. You just change what's after the equal sign. You undo minus 4 by adding 4. You do it to both sides. So you get x's value is 12. That's one of the answers. Same step, you undo minus 4 by adding 4. Do it here. X is negative 4. So both answers, negative 4 and 12. Negative 4 and 12. Negative 4 and 12. Solving an absolute value equation. So now, the difference between example number 1 and example number 2 is the absolute value is not isolated from the jump. It says the absolute value of 3x minus 7, and then they got a plus something. In this case, it says plus 5 is equal to 9. You still do your order of operations. You still undo them backwards. So you undo plus and minus before you undo the grouping symbols, which we call parentheses, and please excuse my dear Aunt Sally. So for the first step, undo plus 5 by subtracting it on both sides. So now notice now we have 3x minus 7 is equal to 4. Then it becomes just like example number 1. Set it up as equal to 4 and as equal to negative 4. So for the first one, 3x minus 7 equals positive 4. Undo minus 7 by adding 7 to both sides. 3x equals 11. Then undo 3 times x by dividing by 3 on both sides. X is equal to 11 over 3, which again is the same thing as a mixed number, 3 and 2/3. You can also set it up as the negative value. You don't have to redo this first step where you subtract 5 on both sides. You already did that part. But at this step, 3x minus 7, make it equal to negative 4 this time, not positive 4. Add 7 to both sides, and you get 3x is equal to 3. Get rid of 3 times x by dividing by 3 on both sides, and you get x is 1. So you have two answers. You don't have to write both forms of this answer here. You have two answers. They use the mixed number form, 3 and 2/3 and 1. And again, you could check those by plugging them both back in. 3 times 1 is 3. 3 minus 7 is negative 4. The absolute value of that is 4. 4 plus 5 is equal to 9. That's true. The same thing's true with 3 and 2/3, or 11 over 3 is probably easier to plug in. 11 over 3, 3 times 11 is 33, divided by 3 is 11. 11 minus 7 is 2. The absolute value of 2 is 2. I'm sorry, 11 minus 7 is 4, excuse me. The absolute value of 4 is 4 plus 5 is in fact equal to 9. So both of them check out. Again, on the back, do this one. The absolute value of 5 plus 1 plus 3 is equal to 14. Take about a minute on this one. Remember, you don't have to redo the plus 3 part both times. Just set it up as both positive and negative. So again here, make it look like example number 1 by undoing this plus 3 first. Subtract it. The absolute value of 5x plus 1, again, make sure that's bigger than your normal writing to where you can tell, is equal to 11. Okay, remember, you're trying to get the absolute value by itself. You're trying to get all the operations outside of it on the other side of the equation. So now, set it up as two separate problems. As a positive one, 5x plus 1 equals 11, and as a negative one, 5x plus 1 equals negative 11, both positive and negative. Undo plus 1 on both sides by subtracting it. 5x is equal to 10. Undo 5 times by dividing it. X is 2. There's one of your answers. The other one, again, undo the plus 1 by subtracting it on both sides. 5x equals, this time, negative 12. Divide by 5 to get rid of 5 times. X is negative 12 over 5. There's no number that goes into both of those. Both of those go into it. Again, when you plug them both back in, 5 times 2 is 10 plus 1. The absolute value of that is 11. 11 plus 3 is 14, so 2 works. Negative 12 over 5. 5 times negative 12 is negative 60. Negative 60 divided by 5 is 12, or negative 12. Negative 12 plus 1 is negative 11. The absolute value of negative 11 is 11 plus 3 is also 14. So that's how you check both of those by plugging them back in. Now, absolute value inequalities when you're talking about absolute value is almost the same thing. There's always a little something different. The little something different is when you change the sign. A minute ago, we made one of them positive, the other one negative. That was with equations. With inequalities, when you change it from positive to negative or from negative to positive, you reverse the sign. So the absolute value of ax plus b, when it's less than c, it's ax plus b is less than c. You write it just like it is. The other one is ax plus b. You change the sign from less than to greater than, and you change the sign from positive c to negative c. Also note what it says out in the bubble. It says, notice that when an absolute value is less than a number, the inequalities are connected by and. So less than makes and compounds. Greater than makes or compounds. So the same exact thing's true for the ones that are or equal to. There's nothing different with those. The ones that just say equal are the ones we just did a second ago. You make one positive and the other negative. Those are typically easy for students. And then the greater than ones, you do the same thing. You reverse the symbol and change the sign. But instead of being and in the middle, these are or. The ones that are less than are and. The ones that are greater than are or. Reverse the symbol, change the sign. Just like with equations, you change the sign. But for these, you need to reverse the symbol and change the sign. Let's take a look at a less than inequality. 5x, or the absolute value of 5x minus 7 is less than or equal to 23. So it's less than. This is going to be an and inequality. The first one, you set it up just like it says without the symbols. 5x minus 7 is less than or equal. It's going to be to positive 23. So remember, you treat it just like an equation. Undo minus 7 by adding 7 to both sides. 5x, you don't need to reverse the symbol. All we did was add 7. 5x is less than or equal to 30. Get x by itself by dividing by 5 on both sides. X is less than or equal to 6. Again, you didn't need to reverse the symbol because we divided by positive 5. You also do it the other way. The absolute value of 5x minus 7, you reverse the symbol. Less than or equal to becomes greater than or equal to, and positive 23 becomes negative 23. So you need to reverse the symbol and change the sign. That is the biggest deal with inequalities. Make sure you reverse the symbol and change the sign. Everything else is the same. Undo minus 7 by adding it to both sides. Negative 23 plus 7 is negative 16. Then divide by 5 on both sides. You don't reverse the symbol here, even though it comes out to be negative 16 over 5, because we're dividing again by a positive number. So negative 16 over 5, which is the same thing as the mixed number, negative 3 and 1, 5. Therefore, the solution is all real numbers that are greater than or equal to negative 3 and 1/5 and less than or equal to 6. Remember, this is an and inequality because it says less than, or which can be written as the and inequality. Negative, you could just as easily have written as negative 16 over 5 is less than or equal to x and less than or equal to 6. And we worked compound inequalities before the break. This is something we've done. It's going to take you a little while before you're super comfortable doing it, but you will get there. On the back again, solve this one. The absolute value of x plus 6 is less than 8. Take about 1 minute. Remember, reverse the symbol, change the sign. Okay, the absolute value is isolated. So make one of them say x plus 6 is less than 8, just like it says. Make the other one say x plus 6, reverse the symbol, make it say greater than, and change the sign from positive to negative 8. So that's how you set up both of them. And it's going to be an and inequality since it's less than. Undo plus 6 by subtracting it on both sides. X is less than 2. Undo plus 6 again by subtracting it on both sides. X is greater than negative 14. This is an and inequality. You can't simply write the word and in the middle. You need to put X in the middle. Okay. That's less than 2. That's the same as that one there. And make the symbol go the same way, negative 14 for this one. This is the solved version. Greater than negative 14 and less than 2. The other type of inequality is when it's greater than. These are typically easier for students because you make or ones. Or ones are easier than and ones. Again, this one says the absolute value of x minus 11 plus 2 first. Before you can undo the absolute value part, you got to undo the plus 2. We know how to do that. You undo it by subtracting 2 on both sides. So 8 minus 2 is 6. So now you got the absolute value of x minus 11 is greater than 6. So remove the absolute value symbols and leave it. Just say x minus 11 is greater than 6. Undo minus 11 by adding 11 to both sides. X is greater than 17. Simple. Do the same thing on the other side. You don't have to redo this part. You already did this part. But this time, take it from inside the absolute value symbols, get rid of them, still have it say x minus 11, but now reverse the inequality, make it say less than, and change positive 6 to negative 6. So now you got x minus 11 is less than negative 6. Add 11 to both sides, and you get x is less than 5. So this would simply be written as no, all real numbers greater than 17 or less than 5. And notice it's just written as two inequalities with that word or jammed in the middle to make them a compound. That's the difference between and inequalities and or inequalities. And is less than or is greater than. And again, one more time on the back. The absolute value of 3x minus 3 plus 4 is greater than or equal to 10. Again, before you try to undo the absolute value, you need to undo this plus 4 part by subtracting it. If you do it there, do it here. Now you got something that says the absolute value of 3x minus 3 is greater than or equal to 6. If we had divided or multiplied by a negative value right there, you'd have to reverse the symbol. That hasn't changed. Now, this is a greater than one, so it's going to be or in the middle. We'll write the first one to say 3x minus 3 is greater than or equal to 6. Or the other one will say 3x minus 3 is less than or equal to, notice we reverse the symbol, and positive 6 becomes negative 6. Undo minus 3 by adding 3 to both sides. So you have 3x is greater than or equal to 9. Divide by 3 on both sides. X is greater than or equal to 3. That's one of them. The other one, undo minus 3 again by adding 3 to both sides. 3x is less than or equal to negative 3. Divide by 3 on both sides. X is less than or equal to negative 1. Again, since this was a greater than one from the jump, it's simply or. X is greater than or equal to 3, or x is less than or equal to negative 1. And then we have 4 checkpoint problems we need to look at. The absolute value of x minus 3 is equal to 7. Set it up as 2 problems. X minus 3 equals 7 and x minus 3 equals negative 7. Undo minus 3 on both sides. X is 10 is one of them. The other one, still undo minus 3 on both sides. X is negative 4. Remember, equals one is or in this case, and. I got it confused, excuse me. X is equal to 10 and x is equal to negative 4. Same thing with this one. Set it up as 2 separate problems. 4x plus 10 is equal to 34 and 4x plus 10 equals negative 34. Undo plus 10 by subtracting it on both sides. 4x equals 24. Undo 4 times by dividing it on both sides. X is 6. The other one, same thing, same step. Subtract 10. 4x equals negative 44. Divide by 4 on both sides. X is equal to negative 11. So x is 6 and negative 11. So that's equations. They're easy. You just set one positive, one negative. Inequalities are just as easy. You just have to make sure, remember when you reverse the sign to reverse the symbol, change the sign. 3x is greater than or equal to 18, and 3x is less than or equal to negative 18. Divide by 3 on both sides. X is greater than or equal to 6. Divide by 3 on both sides. X is less than or equal to negative 6. That's a greater than one. Greater than means or, so it's x is less than or equal to negative 6, or x is greater than 6. Same thing with this one over here, but it's less than, so it'll be equal to. X minus 7 is less than 16. X minus 7 is greater than negative 16. Reverse the symbol, change the sign. Undo minus 7 by adding it to both sides. So x is less than 23. Again, undo minus 7 by adding it to both sides. X is greater than negative 9. This is an and inequality, so negative 9 is less than x, which is less than 23, is how that one would be written. I got my symbols wrong. Remember, make sure the mouth is eating the same one. The mouth is eating the X.